Hey everyone, today we're going to talk about the single pixel attack. In the last video we talked about the FGSM, which was using a mathematical process to add noise to an image and fool an AI classifier. Well, in the single pixel attack, we add noise to a single pixel and we're able to fool poorly trained AI models. Well, let's get started with some code so you can see how to implement this attack. Put some header information up on the top. We know what we're doing, and then we'll do the imports. I have to do pip install TensorFlow because my environment is Google Colab. You may not have to do that on your environment, though. All right, let's get our data. You can see these code suggestions are from the AI agent that Google is using. It can be useful to shorten some of the code. Often, though, it's frustrating because it'll give the wrong suggestion and you have to go back and fix it. It's up to you, though, what your preference is. You can see here I only used 500 images. That's very small, and you wouldn't normally do this. I only used a few. That way, when we run our attack, it goes by much quicker. All right, you can see what one of these images looks like. That's a hand-drawn 7. Now let's write some of our functions. Our first function is just to create our model that we're going to call in our main function. Let you pick the optimizer or the activation parameter that you want. You can see this is going to be a pretty simple sequential model with just 3 layers. You got the input layer, you got 2 dense layers, and then an output layer. I guess that's a total of 4 layers, not 3. No, actually it is 3 layers. We're going to define our loss function. Right now, let's write the function for the single pixel attack itself. So we're going to pass it the model that we're trying to fool, and then the data set that we're going to add the single pixel attack to. You can see in the description I said a multi-pixel attack. That is because you could do multiple pixels, not just one. All you would have to do is change the number later in our code that we'll see. So you can see right here we're doing copies of data sets. That's because if you just set a variable to the data set and trying to create a copy, when you try to change that copy, you'll change the data set itself. If you do this, it will add a lot of time to what you're doing. All right, you can see right here we have 2 loops, one for an image and all the data, so we're going through all of them, and then we're also looping through all the pixels in each image. Normally, it's pretty bad practice to have a lot of nested for loops. However, to my understanding, this is the most efficient and only way that I know to go through all the pixels and add noises to one until we find the one that matters. You can see right here, we'll check to see the predictions to see if once the noise is added to a specific pixel, does the model itself change its prediction. And if it does, we'll get a little message telling us, and then we've completed our attack. And then we're going to print a little warning just in case we didn't find it. All right, let's write our main code and call these functions. All right, there's our baseline model. You see it's only has an accuracy about 86%. Accuracy is only one of the metrics, but it's pretty simple for demonstration purposes. All right, let's run the single pixel attack, and then let's see the image after it. Oh, looks like I made some typos. Let's see. I put minus instead of equals. There's some of those code suggestions I was talking about. Sometimes it suggests the wrong thing. Make sure we do the copy of the data set. Spell data set instead of data. Let's see if this works now. There's another typo. All right, now this will run for several hours. I paused the video and showed it after it was done. This might take, honestly, 3 to 4 hours. You can see right here how we added 1 pixel to that handwritten 9, and then it confused the model and it mispredicted it as a 9. It no longer predicted it as a 9. This may seem like an academic example, and it is. However, it's a good demonstration of being able to add noise, whether that's digital noise or physical noise, to an image to not confuse a human, but to confuse an AI classifier. This is something you need to be aware of as a developer and then also as a security engineer. Well, I hope you enjoyed the video. Like and subscribe. We have several other videos if you want to see more ways to hack AI models.